Welcome to the first video of Pick and Place series by CNCTrain. The process of creating a workcell starts by creating a workstation, importing the robot pedestal, importing robot model, and moving forward with the sequential process. In today's video, we will be performing the first activity, which is creating a new workcell. We will learn to import various station components into the workcell layout. There are two modes in Robot Studio. View mode, it will demonstrate the robotic pick and place operation, and try mode, which will help you with the needed practice to perform robot pick and place operation. Let us proceed to the video and understand the procedure of creating a new workcell.
The view mode will demonstrate you the robotic pick and place operation. The try mode will help you with the needed practice to perform the robotic pick and place operation. Let's get started with activity 1. Welcome to this demo on creating a new robotic workcell. In this demo, you will learn to import the various station components into the workcell layout. Let's get started. Click or press Next to continue. Click Robot Studio V6.05 on the desktop to open the program. Robot Studio is an application used for modeling CAD objects, robot offline programming, and simulation of robot cells in a virtual environment. Let's now see how to create a new workstation. A typical robotic workstation consists of robots, IRC5 controller, flex pendant, robot pedestal, tools, grippers, positioners, conveyors, safety fence, and CAD objects. Click or press Next to create a new workstation. Select the File tab. Select New. Under Stations, double-click Empty Station. The Empty Station option helps you to create a new workstation or import an existing one, and select the robot and controller you want. Now, you will learn how to import the robot pedestal into the workstation. The robot pedestal is the main supportive member, which is the base of the robot and gives support as well as stabilization to the robot. It helps you adjust the height of the robot to suit workspace requirements. Click or press Next to import the robot pedestal. On the Home tab, in the Build Station group, click Import Library. The Import Library option allows you to import equipment, geometries, positioners, robots, and tools to the workstation. Select Equipment. The Equipment option, when selected, displays a list of predefined ABB mechanism libraries such as pedestal, conveyor, fence, and so on. Select the robot pedestal you want to add to the workstation. Scroll down to view the other section. In the other section, double-click Robot Pedestal 1400H240. Note that a robot pedestal is 660 mm in length, 490 mm in width, and 240 mm in height. Now, the robot pedestal is imported into the workstation. Next, you will see how to import the robot model into the workstation. The IRB 2600 family contains 3 robot models, each having a handling capacity of 12 to 20 kilograms. These robot models are designed to increase the productivity in machine tending, material handling, arc welding, and other process applications. It contains 3 versions, 2 short arm variants, 1.65 meters, 12 or 20 kilograms payloads, and a long arm variant, 1.85 meters with a 12 kilograms payload. Click or press Next to import a robot model. On the Home tab, in the Build Station group, click ABB Library to import the robot into the workcell. The ABB library can be used to choose robots, positioners, and tracks from their respective galleries. The robots gallery opens. Select the IRB 2600 robot model. IRB refers to the industrial robot body, and the number 2600 represents the robot model series. In the IRB 2600 dialog box, click OK to import the robot model. Note that the capacity of the robot payload is 12 kilograms and robot reach is 1.65 meters. Click Zoom All to view all the components of the workstation. Note that the robot and pedestal are at the same position. The robot must be positioned at the top of the pedestal. Now, let's see how to position the robot from the bottom to the top of the pedestal. Click or press Next to position the robot. On the Layout tab, in the Mechanisms group, right-click IRB 2600_12_165_02. Select Position to modify the robot's position. The Position option allows you to locate and orient the robot in the workstation. Select Set Position. The set position IRB 2600_12_165_02 pane is displayed. The position XYZ, MM and orientation degree fields represent the world coordinate system of the workcell. The X, Y and Z coordinate axis values are expressed in units of millimeter, while the angle values are expressed in units of degree. Double-click in the Z coordinate field. Enter the value for the Z coordinate. In this case, type 225 mm and press Enter on your keyboard. Now, the robot moves vertically up from the pedestal along the Z-axis in a positive direction. In the set position, IRB 2600_12_165_02 pane, click Close. Now, you will learn how to set the robot at its home position. The home position is the position where the robot starts and completes its task. This is the safe position to park the robot. On the Layout tab, in the Mechanisms group, right-click IRB 2600_12_165_02. Select Mechanism Joint Jog. Now, the joint jog IRB 2600_12 underscore 165 underscore 02 pane is displayed. Note that the mechanism joint jog allows you to move the individual robot joints. Each row in the joint jog pane represents a joint of the robot. You can move the joints either by clicking and dragging the bar at each row or by using the control arrows to the right of each row. The value in the CFG field represents the current configuration value. The value in the TCP field represents the current position of the tool center point, TCP. And the value in the step field represents the length of the joint movements for each click of the buttons to the right of each joint row. In the fifth row of the joints jog, IRB 2600 underscore 1 2 underscore 165 underscore 02 pane. Double-click the right arrow until you set the value as 90 degree. Click Close to close the joint jog pane. Notice that the robot is set at its home position. Let's now see how to import Conveyor 1 into the workstation. The Conveyor 1 system is defined to transfer the plastic storage crates. Click or press Next to import Conveyor 1. On the Home tab, in the Build Station group, click Import Library. Select Equipment. In the Conveyors gallery, select Conveyor Guide. Note that the Conveyor Guide is 400 mm wide and 3000 mm long. Click OK to import it into the workstation. Click Zoom All to view the other components on the workstation. On the Layout tab of the left pane, under the Components group, right-click 400 Guide. Select Position to modify the position of the conveyor. The Position option allows you to locate and orient the conveyor in the workstation. Select Set Position. The Set Position 400 Guide pane is displayed. Double-click in the X-coordinate field. The position XYZ, mm, and orientation degree fields represent the world coordinate system of the workcell. The X, Y, and Z coordinate axis values are expressed in units of millimeter, while the angle values are expressed in units of degree. Type in the X-coordinate value. In this case, enter minus 1150 mm. Now, the conveyor gets positioned along the X-axis in the negative direction. Double-click in the Y-coordinate field. Type in the Y-coordinate value. In this case, enter 750 mm and press Enter. Now, the conveyor moves and gets positioned along the Y-axis in the positive direction. Double-click in the Z field to set the orientation about the Z-axis. Enter the orientation angle. In this case, Type in -90 degree and press Enter. Now, the conveyor 1 rotates about -90 degree along the Z-axis. Click Close to close the set position 400 guide pane. Let's now see how to import conveyor 2 into the workstation. The conveyor 2 system is used to transfer the packaging boxes. Click or press Next to import conveyor 2. Click Import Library to load the conveyor 2. Select Equipment. In the Conveyors section, select Conveyor. Note that the conveyor is 950 mm wide and 4000 mm long. Click OK to import the conveyor 2 into the workstation. On the Layout tab, right-click 950.4000.H2 to modify the position of the conveyor. Select Position. This option allows you to locate and orient the conveyor in the workstation. Select Set Position. The position X, Y, Z, mm, and orientation degree fields represent the world coordinate system of the workcell. The X, Y, and Z coordinate axis values are expressed in units of millimeter, while the angle values are expressed in units of degree. Set the values for X and Y coordinates. In this case, type -325 mm and 670 mm, respectively, and press Enter. Now, the conveyor 2 is positioned parallel to the robot's initial position. Click Close to close the pane. Click Zoom All to view all the components. Next, you will learn how to import the plastic storage crate into the workstation. The robot will pick up the plastic storage crate and place it in the packaging box. The plastic storage crate will then be transferred to the robot pickup position by conveyor 1. Click or press Next to import the plastic storage crate. On the Home tab, in the Build Station group, click Import Geometry. The Import Geometry function allows you to import CAD files of the workcell components. It supports file formats such as IGES, IGS, STEP, and STL of 3D CAD. An IGS file is a graphics file saved in a 2D or 3D vector format based on the initial graphics exchange specification, IGES. It can store wireframe models and surface or solid object representations. In the Browse for Geometry dialog box that opens, select the box .IGS file. Note that the box is a CAD file in the .igs format. Select the Convert CAD Geometry to Single Part checkbox. Click Open. Zoom in the work area to view the imported box CAD component. On the Layout tab, in the Components group, right-click Package Box. Click Position. The Position option allows you to locate and orient the box in the workstation. Then, select Set Position. Now, the Set Position box pane is displayed. The X, Y and Z coordinate axis values are expressed in units of millimeter, while the angle values are expressed in units of degree. Set the values for X, Y and Z coordinates. In this case, type in minus 950 mm, 600 mm, 770 mm, respectively, and press Enter. Note that the value of X is the distance of the plastic storage crate from the origin of the work object coordinate system to that of the world coordinate system. In the orientation field, in the X position, enter the value for the orientation. In this case, type in 90 degree. Press Enter. Now, the box rotates 90 degree clockwise with respect to the X-axis. Double-click in the Z orientation field to set the angle of rotation about the Z-axis. In this case, type in 90 degree. Press Enter. Click Close to close the pane. Now, the plastic storage crate is positioned and aligned with conveyor 1. Now, you will learn how to import the packaging box into the workstation. Click or press Next to import the packaging box. On the Home tab, in the Build Station group, click Import Geometry. In the Browse for Geometry dialog box that opens, select the package box.igs file. The packaging box is a CAD file in the .igs format. Select the Convert CAD Geometry to Single Part checkbox. Click Open. On the Layout tab, in the Components group, right-click Package Box. From the list, select Position. This option allows you to locate and orient the packaging box in the workstation. Then select Set Position. The X, Y and Z coordinate axis values are expressed in units of millimeter, while the angle values are expressed in units of degree. Set the values for X, Y and Z coordinates. In this case, type in 700 mm, 850 mm and 425 mm respectively and press Enter. The value of X is the distance of the packaging box from the origin of the work object coordinate system to that of the world coordinate system. Enter the values of the X and Z orientations. In this case, type in 90 degree for both X and Z orientations. Press Enter. In the Set Position Packaging Box pane, click Close. Now, the packaging box is positioned at the top of Conveyor 2. Click Zoom All to view all the components of the workstation. Let's now import Fence 1 into the workstation. The safety fences are used around the robot workcell area to prevent unauthorized entry of people and materials while robot is in operation. The conveyor roller is about 3000 mm long. Now, you will learn to import a pair of 740 mm and 2500 mm length fence into the workstation to create a safety fence at the rear side of Conveyor 1. Click or press Next to import Fence 1 into the workstation. Click Import Library to load the 740 mm Fence 1. Select Equipment. Scroll down to view the other section. In the other section, select Fence 740 to import it into the workstation. Note that Fence 740 is a safety system. The length of the fence is 740 mm long. Now let's set the fence at the rear side of Conveyor 1. On the Layout tab in the Components section, right-click Fence 740 to modify the position of the fence. Select Position and then Set Position. The X, Y and Z coordinate axis values are expressed in units of millimeter, while the angle values are expressed in units of degree. Type the value for the X coordinate of the fence as minus 1310 mm and press Enter. This value represents the total distance between the robot and the fence. Now, the fence moves along the x-axis in a negative direction. Type the value for the y-coordinate as 970 mm and press Enter. This value represents the distance from the origin of the work coordinate system of workcell. Now, the fence moves along the y-axis in a positive direction and gets positioned at the rear side of conveyor 1. Click Close to close the set position. Fence 740 pane. Now, repeat the steps to create fence 2 of the same type. Click Import Library. Select Equipment. Scroll down to view the other section. Set the X and Y coordinates of fence 740 The X, Y and Z coordinate axis values are expressed in units of millimeter. In this case, type in minus 1310 mm and 220 mm respectively and press Enter. Now, the fence moves along the y-axis in a positive direction and gets positioned next to the first fence. Next, you will learn how to import a 2500 mm length fence into the workstation. Import a 2500 mm length fence into the workstation using fence 2500. Set the X and Y coordinates of fence 2500 and press Enter to set the fence at the side of conveyor 1. The X, Y and Z coordinate axis values are expressed in units of millimeter. X minus 1310 mm. Y minus 2280 mm. Now, the fence moves along the y-axis in a negative direction and gets positioned next to the 740 mm fence. The length of conveyor 1 is 3000 mm. These fences can protect even conveyors that are of 3980 mm in length. So, the workscell is well protected. Now, you will import a pair of 2500 mm safety fences in the workstation. These safety fences protect the conveyor 2 roller of the robotic workcell. The conveyor roller is about 4000 mm long. Click or press Next to import fence 2 into the workstation. Import fence 2500 into the workstation. Set the values for X and Y coordinates and Z orientation of fence 2500 and press Enter. The X, Y and Z coordinate axis values are expressed in units of millimeter, while the angle values are expressed in units of degree. In this case, type in 1150 mm, 1800 mm and 90 degree respectively. Import another fence of the fence 2500 type and position it using the values given. The X, Y and Z coordinate axis values are expressed in units of millimeter, while the angle values are expressed in units of degree. Set the values for X and Y coordinates and Z orientation of fence 2500 and press enter. In this case, type in 3660 mm, 1800 mm and 90 degree respectively. The length of conveyor 2 is 4000 mm. These fences protect a length of 5000 mm so that the work cell is well protected. Click Zoom All to see if all the components are positioned correctly in the workstation. Robot Studio allows you to work with an offline controller, which is a virtual IRC5 controller. Here, IRC5 refers to the industrial robot controller that runs locally on your computer. The number 5 represents the version of the ABB controller series. This offline controller is also referred to as the virtual controller, VC. Robot Studio is said to be in offline mode when working without connecting to a real controller or when connected to a virtual controller. Now, you will learn how to import the IRC5 controller into the workstation. Click or press Next to import the IRC5 controller. Use your mouse wheel to zoom in the workstation and right-click to rotate it. Import the IRC5 control module from the IRC5 cabinets section. The IRC5 controller contains electronics required to control the manipulator, additional access, and peripheral equipment. Set the values of X and Y coordinates and Z orientation for the IRC5 control module as 450 mm minus 1400 mm and 0 degree respectively. The X, Y and Z coordinate axis values are expressed in units of millimeter, while the angle values are expressed in units of degree. Now, you have imported the IRC5 controller into the workstation and positioned it. The flex pendant, occasionally called Teach Pendant Unit or TPU, is a handheld operator unit used to perform many of the tasks involved when operating a robot system, such as running programs, jogging the manipulator, modifying robot programs, and so on. The flex pendant is designed for continuous operation in harsh industrial environment. Its touch screen is easy to clean and resistant to water, oil, and accidental welding splashes. Now, you will learn how to import a flex pendant into a workstation. Click or press Next to import the flex pendant. Import the flex pendant from the other section and set the position values for X, Y, and Z. In this case, enter 400 mm, minus 1350 mm, and 741 mm respectively. The X, Y, and Z coordinate axis values are expressed in units of millimeter. When the value is set in the X and Z fields, the flex pendant moves along the X and Z axis in a positive direction. When the value is set in the Y field, the flex pendant moves along the Y axis in a negative direction. Type in the value for the X position of orientation as minus 45 degree to set the angle of orientation about the X-axis and press Enter. Now, the flex pendant tilts minus 45 degree to incline with the IRC5 controller. Have successfully imported the different workstation components into the workstation.
We hope this video was informative and interesting for you. Visit our website www.cnctrain.com to know more about our product and service offerings. New video releasing every Friday. Thank you.